Good morning to all. My name is Kumar, Department of Physics. MSc, B.Ed and PhD pursuing. Set also qualified. Today we have discussed about any logic gates. So in the logic gate systems, we have three primary gates. Three primary gates. So that is AND gate, OR gate, and NOT gate. Right. So first of all, in the AND gate system, AND gate system. So in this AND gate, physical circuit symbol and truth table. We have to discuss not only AND gate, OR gate, and NOT gate, and remaining NAND, NOR, and XOR gates. Okay, so first of all, the AND gate, symbol. Okay, then the symbol of AND gate is, so in this gate we have to use the two inputs, that is A, B. That is A, B. So this is the symbol of our AND. Okay, this is A and B inputs. Then output is A dot B. So dot product A and B is nothing but A dot B. That is the output of our AND gate. A dot B. Okay, right. This is a symbol. AND gate symbol. Right. So next one is the AND gate circuit symbol computed in the circuit. Right. So in this circuit, so on screen we have two diodes. These are two diodes we have to connected. So plus 5 volts we have to add it in the inputs, and outputs is there AB, and finally Y is A dot B, or A and B gate. Okay, these are circuit. So next one is in the physical diagram of our AND gate. So physical diagram is is a battery. This is the battery positive and negative terminals. In the negative terminal, we have to connect it to LED bulb. So is a positive also connected to the LED bulb, but In the positive terminal, we have to use the two. We have to use the two signals, input signals, that is A and B. Two terminals we have to use them. That is A and B. A and B. Right. This is a physical circuit. Right. So after that, then we have to discuss about in the truth table. Truth table. Okay. So in the truth table, it is depend on our circuit diagram. Physical circuit diagram. Okay. So in the physical circuit diagram, it is tells about our truth table. Truth table. So in the truth table is the truth table is table truth. So inputs in the gate inputs is A and B. A and B. Then output is that one, that is A dot B. A dot B. Right. So two input terminals we have to connected in the input term. Right. So in the two inputs, maximum probability of binary number system is 0 and 1. 0 and 1 in the A terminal and B terminal also. A terminal and B terminal also. The combination of 0 and 1 in two terminals is like this. You see that one. In the first one, A terminal combination is 0, bits is 0 and 1. Is the second one terminal, bits is 0 and 1. In the 0 and 1 combinations is the maximum probability numbers is 4. How can we find out the possibilities, maximum probabilities numbers? Just you see that one. In the 0 combination, the terminal of A, 0 combination, the terminal of B, 0 to 0 and 0 to 1 is the first one. These are first one. So next one is in the A terminal, 1 to 0 is the first one combination. Next one is a 1 to 1 is the second one combination. Completely how many combinations? 1, 2, 3 and 4. 4 combinations. Okay. So 4 maximum combinations or maximum probabilities. Okay. So that's why in the A to B combinations, first one is 0, 0, 0, 0. Second one is 0 and 1, 0 and 1. Then the third one is 1 to 0, 1 to 0. Finally, then 1 and 1. It is here. It is here. Right. So next one, in the it is output. This output is it is depend on our physical diagram of AND gate. Okay. So in the first one is in the terminal. The terminal, you see that one. The first one and the second one. Okay. So these are A and B. In the first one is what is that? 0 and 0 is there. 0 and 0 is there means 0 and 0 means these are lower value, lower both or it is lower values. Lower values means what is that? Is a flow of it is no flow of current. So these are false number. So means is a circuit is opened. There is a lower value. Higher value is circuit is connected. When the circuit is connected, then the bulb also it is glowing. Okay, so that's why then the A and B, both terminals, it is open. These are open stages. These are open. Okay, right. These are negative terminal is it is directly connected to in the LED bulb. These are positive terminal. We have two inputs. These are A and B. These are both or it is open. Then the output it is value is zero. Zero means that the light it is not glowing. Right. This is the first one. A dot B. So next one is in the second one. The second one value that is 0 and 1. 0 and 1. So in this one, A is 0. A is 0 means A is open. Then the B is 1 means B is closed. So automatically, what is the value of our output term? Okay, A is 0. This A is 0. B is 1. So what is that? Is a automatically it is open. Open means is a light. It is not glow. Light. It is not glow. Means there is a value of A dot B is 0. That it is clear. So next one is in the 1 and 0. 1 and 0 means A is 1 means it is closed and B is open. Then output value also is 0. It is 0. Finally, in the both are closed. Both are it is closed. So automatically then the positive terminal of our circuit is connected to in the LED bulb. Okay. So then the LED bulb is it is glowing. Glowing means is a value is 1 is 1. 1 is 1. Right. It is clear. It is clear. Right. So finally, what is the output values of AND gate is 0, 0, 0, 1. Okay. So in the inputs 1, 1, then output also 1. These are I combination of I, then output also I, then the remaining is low. Then the remaining is low. Right. So how can we write the definition of an AND gate? Right. So in the definition, it's come to our truth table. Okay, it's come to our truth table. How can we write it? You see that one. The combination of input combination of high or true, then output. What is that position? It is also high or true. Right. So other one is these are 0 or low value or false. Right. Definition: two inputs, one or more, or two or more inputs. Right. Two or more inputs. I, then output also I. Then output also I. Then remaining output all values is low. All values is low. That is AND gate. It is very easy, right? So inputs, both inputs is low I, then output also I, then the remaining is low. That is AND gate definition. AND gate definition. Okay, right. So this is the AND gate. Similarly, then OR gate also, or gate also. Okay, so and our on the screen, case one is 0 0, case 2 is 0 1, and case 3 is 1 0, and case 4 is 1 1. Okay, that is the explanation about case by case. The case case 1 to case 4, then values we have to explain. In the explanation we can show on the screen, right? So next one is in the or gate. Or gate. So or gate. the OR gate. First of all, the symbol, OR gate symbol is, this is OR gate symbol, A and B. Then output is A plus B. A plus B is a symbol, OR gate symbol. OR gate symbol. Then circuit, that is two diodes. Two diodes is a forward that connected to in the inputs. After that, then you will get the output, that is A plus B value is there. So you see the circuit. So next one is in the physical diagram. So you know that one, the physical diagram, it is dependent on our tabular form. First of all, we have tried that physical diagram. So the physical diagram, is a battery, is a positive and negative terminals. So terminal, this is terminal A and this is a terminal B. Is the negative is directly connected to a bulb, which is a physical diagram. Physical diagram. So the truth table, it is depend on our physical circuit diagram. Physical circuit diagram. So in the inputs is AB and outputs is A plus B. Outputs is A plus B. So the before one, we have to discuss about in the possibilities of two combinations, that is 0, 0, 1, 0, 0, 1, and finally that is 1, 1. 1, 1, that is the input values. Input values. So next one is, then output is negative terminal is directly connected to into LED bulb. There is a positive terminal. In this between, we have to use the two input values, that is A and B. A and B. So A and B both are open, means that is 0, 0. So both are open means that is 0, 0. So both are open means is a positive value is disconnected to our LED bulb. So that's why then the bulb it is not glowing, then value is 0. Then value is 0. So next one is the A terminal, we have to connect it to the bulb. The B terminal is open. So what is the position of our LED bulb? Right. So positive terminal, it is connected to A, means there is a directly it is connected to in the LED bulb. LED bulb. So then value is a high, that is 1. In the same way, in the A is open, B is closed. So means is a positive terminal. It is connected to the LED bulb. Then the value is 1. So next one is 0, 1. 0, 1 is there. So finally, then the both or it is closed. Both or it is closed. A and B also closed. So A and B also closed means is a positive terminal. It is connected to, directly connected to into in our LED bulb. So then the LED bulb is, it is glowing. Glowing means value is 1. Value is 1. Right. So A plus B output values is 0, 1, 1, 1. These are output values. Right. So how can we define the OR gate definition? OR gate definition. Right. So in the input terminals, common terminals, these are common terminals. This the value is common value. This one also common value is there. But in the output 110 is the remaining 111, then remaining 110 is there. But it is not suitable. So that's why you have to select the 000, then remaining is 1 is there. Okay, so that's why then you have to select it to another definition purpose. Right. So how can we write the definition of an or gate using that one? The input terminals is low, that is zero, low. Then output also zero or low. Output also zero or low. Remaining is it is I of an or gate outputs. Once again repeated, in the input terminals low or zero, then output terminal also low or zero. Then remaining is I or 1. I or 1 of an or gate output values. That is the OR gate definition. OR gate definition. Right. This is the OR gate. So next one, finally, in the NOT, NOT, NOT gate. So NOT gate is nothing but a inverse gate. Inverse. Okay. So in the NOT gate, in this NOT gate, that is the only one input and one output. One output. One input and one output. Right. So in the one input and one output is a battery. So sorry, just I say the symbol, not gate symbol. These are not gate. Right, these are not gate. These are not gate. Not gate symbol is A. Is the what is the bubble? That is A bar. It is a not importing not gate. A and A bar. A and A complement. A and A complement. So complement means the opponent value, opponent to then other value. That is nothing but a complement. It is a complement. Okay. So in this one is circuit diagram also displayed on the screen. These are only input and one output. Then 5 volts we have to connect it to battery. So these are circuit diagram. So next one is the physical diagram of our NOT gate. Physical diagram of our NOT gate. This is battery. This is battery. So this is LED bulb. Directly you are connected. So terminal A. So you are connected. It's like it is a A input, then output is A bar. Output is A bar. Okay. So in the positive terminal is positive and is a negative terminal. Positive and is a negative terminal. So first one is in the truth table. The truth table. So in this truth table, these are truth table. So we have used only one input and one output. That is possibilities in 0 and 1. 0 and 1. Right. So the 0 and 1 possibilities, it is depend on our physical circuit diagram of all output values. You know that one. So first of all, in the first of all in the 0 value got applied. So means A is open. So automatically, then the positive value it is connected to LED bulb. Is the negative also it is connected to LED bulb. So bulb is glowing. Then what is the output value is 0 place in the input 0, then output 1. So next one is then the A value is 1. A value is 1. So A value we have to connect it. We have to connect it. So what is that process? Positive terminal and negative terminal both are it is connected. So both are it is connected. So what is that process? Then the fuse. Then the fuse is, is of fuse is it is damaged. So fuse is damaged means then bulb is it is not glow. So means then the value of our one of input then output is zero. Output is zero. So input values always is opponent to the output values. Okay, you can see the in our tabular form. You have to verify 0 and 1, 1 and 0 you will get it. Is a NOT gate circuit. Okay, so next one is simply you see the definition of our NOT gate. Okay, then so the definition is whatever is the input this case inverse or complements in output is output. That is I in the input value low on the output where these are opponents. These are opponent values. That is not it. So next one is NAND, NAND, NAND. Right. So what is a NAND? Is the application of our not and gates. The combination of not and gates. There is nothing but a NAND gate. So NAND gate is so NAND gate. So next one is NAND NAND gate. NAND gate is right. So NAND gate is combination of and plus not. This is nothing but a NAND gate. NAND gate. So first of all, we have to see the symbol of our NAND gate. So NAND gate symbol is first of all we have to write the AND gate. This is AND gate. You know that one. This is the AND gate. These are terminals, input terminals A and B. Then output is that is A NAND gate and is you know that one in the AND terminals this is A dot B where to use it. So that's why then the A dot B right it is here in the A dot B is the terminal output terminal. Right. So after that, in the AND gate, we had the NOT gate. Is a NOT gate is that is terminal only one input and this is a symbol for NOT gate. Then one output is a complement of gate. These are and these are NOT. So both are we have to connected you have to connected. So that connected symbol, combination of symbol is you see that one. This is the symbol A and B. So in the output we have to use the bubble. Okay, so this is a combination of and not, and this is and, so not, then you can use the bubble, that is not. So finally you will get the NAND gate, NAND, NAND gate. Right, is the output, input and the input. Two terminals we have to use it, the two terminals, the combination of and not, then finally we get the NAND gate. Okay, these are NAND gate symbol. So next one is, so next one is, so next one is in the, after symbol we have to, we have to connect the circuit values. These are circuit. So these are two diodes. Two diodes we have to connect it to the transistors. The transistors. So output values. You see that one. These are A and B values. So the NAND gate table, truth table. Okay. So truth table is, truth table is A and B, A and B. These are A plus B, sorry, A dot B in the AND gate is A dot B in the complement of A dot B bar. A dot B bar. How can we write the A dot B complement? So in the A dot B is AND gate, then the complement is not gate, so that's why A dot B complement is AND gate and not gate combination, that is A dot B, that is nothing but a NAND gate. So that's why we have to write the A dot B complement. A dot B complement. The A value and B value is the maximum possibilities is 0 0. You know that one, 1 0 and 0 1. Another one is 1 1. Another one is 1 1. Right, this clear. So you know that one in the A dot B values, A dot B values. So once again you see that one in the A dot B values. So A dot B values is all is 0 only, 1 1 is 1. That is A dot B or AND gate values, AND gate values. So directly you can write is 0 0 is 1, 1 0 is 0, 0 1 is 0, then 1 1 is 1. Right. For example, in the examination, is the examiner we have to ask to NAND gate. So that's why first of all we have to write the AND gate circuit. AND gate circuit like this. You know that one in the AND gate circuit. What is that? Is a battery. So this is the first one terminal. These are A. Second one terminal is B. Directly but connected to the LED bulb. A and B. Both are connected. Then positive terminal is connected. Means positive terminal is connected. Remaining is, that is 0. So that's why then it has the values negatively. So next one is the A dot B complements. Means A dot B values opponent is A dot B complement. Okay, so that's why in the 0 opponent is 1. Again 0 opponent is 1. 0 opponent also is the 1. 1 opponent is 0. 1 opponent is 0. That is the A dot B complement or NAND gate values. NAND gate values. Okay, so these are NAND gate and symbol circuit and tabular form also. Tabular form also. So next one is how can we define the NAND gate? How can we define the NAND gate? So NAND gate is the, you see that one, all positive values, then output values is, what is that? These are 0. Then what is the definition? You see that one, the both input both input values is high, then output value is low, then remaining is high. That is the NAND gate. This is purely opponent to the AND gate. That is nothing but a NAND gate. So once again, you can check it in the AND gate values. AND gate values is the AND gate values. AND gate values is 0001, 0001. Then the NAND gate values is 111, and 0 is a purely it is opponent to AND gate. So that's why then the definition also is opponent to and the AND gate. So that's why you say the NAND gate. You say the NAND gate. So the definition is once again repeated in the both input values is positive or high, then output value is low or zero. Then the remaining is this is then the remaining is high or it is one. That is one. That is the NAND gate. That is the NAND gate. So next one is after NAND gate, then we have to go to our NOR gate. NO or NOR gate. Right. In the NOR gate it is also opponent to OR gate, or in the combination of OR gate and NOT gate is nothing but a NO or NOR gate. NO or NOR gate. NO or NOR gate. So NOR gate is the combination of OR plus NOT. OR plus NOT. So that is a NOR gate. So how can we write the symbol for and the NOR gate? Okay. So in the NOR gate symbol is first of all we have to write the OR gate. Is the OR gate. Is the OR gate. OR gate. So terminals A and B. So that is A plus B. Is the OR gate plus NOT gate. You know that one is the NOT gate, which is A is the bubble in the A bar is the NOT gate. So both combinations is formed in our NOR gate. So NOR gate is that is A and B is a terminal. Then we have the bubble that is A plus B whole bar, that is the NO or NOR gate. NO or NOR gate. It is clear. It is clear. Okay. So this is a symbol for NOR gate. Then the circuit diagram. The circuit diagram is there. You see that one on screen is the circuit diagram. Two diodes. We have to connect it to in the transistors. So we have to apply the plus 5 volts. Then finally you will get the NOR gate. NOR gate output values is a Y value. You see that one in the on the screen. So next one is in the NOR gate truth table. NOR gate truth table. So truth table, see that one. So A, B, and A plus B, A plus B complement. Right. AND gate A plus B is OR gate, A plus B complement is NOR gate. Right. So in the A terminal is 0, then B terminal also 0. This is the first one combination. Second one combination is 1 and 0. Third one combination is 0 and 1. Finally, then 1 and 1 is the AB combinations. AB combinations. So next one is A plus B. A plus B, that is OR gate or gate combination. So you know that one, OR gate values, output values. So in the definition of an OR gate is, you know that one. What is the definition? OR gate definition is, OR gate definition is both inputs is low, output also low, then the remaining is high. That is 0, 0 value is 0, then 0, 0 value is 0, then remaining values is 1, 1, 1. You know that one in the physical diagram also. Physical diagram. What is the physical diagram? In the combinations, physical diagram is the battery, is the battery. So we have to use the two terminals like this. We have to connect to light LED bulb. This is a positive terminal and negative terminal. This is a terminal A and this is a terminal B. This is a LED bulb. Anyone you have to connect an LED bulb, it is glowing. Okay, so that's why then you can write like this: A plus B, A plus B. Right. So next one is A plus B complement in the opponent of A plus B value. That is a 0 place we put the 1, then remaining is 1 is 0, then 1 is 0, then 1 also it is 0. This A plus B complement is nothing but an OR gate. Is a NOR gate. Yes, it is clear. Okay, so these are NOR gate. So how can we define the definition for NOR gate? Okay, so in the definition is a 0, 0, 0, it is 1, then remaining is values is 0. Okay, so the definition is 2 or more inputs is 0 or low, then output is I or value is 1, then remaining is 0, then remaining is 0. That is NOR N1 or NOR gate definition. Once again repeated, the both inputs are one or more inputs is low or 0, then output is I. Then output is I, then remaining is 0. Then remaining is 0 of our NOR gate outputs. So that is the NOR gate definition. NOR gate definition, right? So these are NOR gate. So first one in the AND gate, NOR gate, NOT gate, so NAND gate, and NOR gate we have to complete it. So next one is in the next one is De Morgan theorems. De Morgan is the theorems. These are most important. These are De Morgan theorems. These are most important question. De Morgan scientists, you have to suggested the two theorems. Okay. So the first one theorem is that is theorem 1. That name is theorem 1. Theorem 1 is the theorem 1. So theorem 1 is A plus B whole bar equal to A plus B whole bar equal to, that is A bar or A complement dot in the B complement. B complement. These are first one here. Theorem 1, A plus B complement, that is equal to A complement dot B complement. So what is the place value? What is the dot value? So you know that one. Okay, so A plus B is or H, A dot B, A complement of A complement and B complement of dot. In this between we have to use the dot is or H. Okay, so finally we have to prove the LHS equal to RHS, then theorem is satisfied. De Morgan, first one theorem is satisfied. So when it is not come to equal values, that is LHS and RHS values, it is not equal, then the theorem, De Morgan theorem, first one is unsatisfied. Unsatisfied. Okay. So in the next one, theorem two is theorem two. The theorem two is A dot B complement equal to A complement plus B complement. A complement plus B complement. That is the theorem number two. Theorem number two. So in the theorem number two, A dot B. A dot B means AB is a AND gates inputs. Okay. Then complements. Then complement. It is nothing but a NAND gate. Okay. So that is equal to A complement plus B complement is there. Okay, so A complement and B complement both are we have to connect it to in the in the in the OR gate. OR gate. Okay, so complement of AB of input of in our OR gate, that is equal to in the NAND gate. We have to prove that. That is the theorem number two. Theorem number two. So what is our proof process? Okay. So first of all, in the theorem one and two also, we have to write the inputs. Okay. So what are the inputs? So you know that one in the combinations 0 0 1 0 0 1 and 1 1. So in the all values we have to apply to the inputs in the same way. So input means in the LHS side, in the same way we have to apply the RHS side also. Okay, both are it is satisfied in the LHS and RHS. So finally we have to do the first one theorem and second one theorem also. Second one theorem also. These are De Morgan's first and second theorems. First and second theorem. So next one is then next one class we have to prove the in the theorem one and two. Just you have to put the AB values. So finally we will finalize the certification of our theorem 1 and theorem 2 process. Okay, so the thank you to one and all. So next one will be discussed in the De Morgan theorems.